Okay, back with you to talk more about fractions. I'm not really sure where to look when I'm on this, so just bear with me. I'm still figuring this all out. But we're going to talk about lowest terms. And basically what lowest terms is taking a fraction that has a larger numerator and a denominator and finding the smallest equivalent fraction that you can find to make those numbers into. So what I mean by that is if I have the number 6/9, I am going to look at 6/9 and I'm going to say, oh, well, 6 and 9 are both divisible by 3, which means I can make those smaller. And so I can make an equivalent fraction by dividing the numerator and the denominator as well as multiplying it. So if I divide both of these by 3, 6 divided by 3 is 2, 9 divided by 3 is 3. So 2/3 is an equivalent fraction to 6/9, and what I've done is I have gotten 6/9 as small as they can get. So I have found a fraction that is in lowest terms. It is as small, the numbers are as small as they can get. In other words, there's nothing I can divide or multiply, or there's nothing I can divide 2/3 by to get those numbers any smaller. If I have, 8/14. Well, what do you know about both of those numbers, 8 and 14? You know that they're both even, which means I can divide 8 and 14 by 2. I just dropped my marker. I'll get another one. 8 and 14 can be divided by 2. So, if I divide by 2, 8 divided by 2 is 4. 14 divided by 2 is 7. Is there anything I can divide 4 and 7 by to make those smaller? No, they don't have anything else in common. So, I am going to say that 4/7 is the lowest terms for 8/14. Now, what words did you just hear me say? You heard me say they have nothing else in common. So that's where your common factors that we talked about yesterday, not yesterday, but in the last video, that's where those common factors come into play. You can find the greatest common factor of two numbers, and that would be the number you would divide by to get lowest terms. Okay? Now, I want to show you what would happen if I did, for example, 8/12 and I did not find the greatest common factor. Okay? So if I don't find the greatest common factor for 8 and 12, I'm going to look at those, and the first thing I'm going to think is that they are both even, so I can divide by 2. Which would be 4/6. But now I can look at 4/6 and say, well, those are both still even, so I can divide by 2 again. 2/3. So now 2/3 is a pretty common fraction that you'll see for lowest terms. So if 2/3 is the lowest terms for 8/12, but I did it in 2 steps because I didn't find the greatest common factor. So I did it with 2 down here and 2 down here. 2 times 2 equals 4. 4 is my greatest common factor. If I had done this 8/12 in 1 step, or if I had found the greatest common factor, 8 divided by 4 is 2. 12 divided by 4 is 3. So I got the same answer, but I did it in 1 step instead of 2. Doing it in 2 steps is not wrong. Doing it in 1 step and finding the greatest common factor just makes it a little bit easier. Oh, excuse my yawn. But it is not necessary to find the greatest common factor every time. It's a good way to do it, and I recommend it. But if you forget or you're not sure, then and your two numbers are even or something like that, you may do it in more than one step. And that's quite all right. So let's find the greatest common, or let's find the lowest terms. Sorry, too many math terms in one day. Let's find lowest terms for 32 over 40. Oops. So here's another one where you're likely going to look at that and say, well, those are both even, so I could divide by 2. But knowing that they're bigger numbers, you're going to probably assume that there's a better option than 2, because they're larger numbers. So I'm going to try 4, because I know that 40 is divisible by 4, and 32 is divisible by 4. So I'm going to try 4. No, I didn't find my greatest common factor. I'm trying to show you both ways. So 32 divided by 4 is 8. 40 divided by 4 is 10. Eight tenths, they're both even. Divide by 2 again, equals 4 fifths. So if I did it in 2 steps with a 2 and a 4, 2 times 4 equals 8. So 32 over 40 divided by 8 on the top and the bottom, because remember, we always do the same thing to the numerator that we do to the denominator. 32 divided by 8 is 4. 40 divided by 8 is 5. So 4 fifths. Okay. So the important thing to remember is that lowest terms gets your fraction to the lowest set of factors that they can go to, where the only thing that you can multiply each number by would be 1, or divide each number by would be 1, sorry. I'm trying not to confuse you here. And then the other thing to remember is that whatever you do to the top, you have to do to the bottom. And when you're finding lowest terms, you're always dividing the top and the bottom by the same number. Okay? Once you get going with Chapter 9, when we're adding and subtracting fractions, you are always going to be asked to put the fraction in lowest terms when you are adding and subtracting. That's going to be true going forward for multiplying and dividing fractions. Anytime you're working with fractions, you are going to have to put them in lowest terms at the end. So it's always dividing by the greatest common factor or something that they have in common to try to get them as low as possible. All right. The next thing on the agenda is mixed numbers. So page 102 talked about mixed numbers, and then that went along with lesson 8.8 in the book. So basically what we're trying to get you to understand in this lesson is that you can have a whole number and a fraction and put them together. So if I have, going back to my pizzas, if I have 2 pizzas and I cut them in half, sorry, I'm going to go 3 pizzas. If I have 3 pizzas and I cut them in half, and, sorry, still trying to figure out the best way to do this. Okay, so here are my 3 pizzas cut in half, and this whole pizza is going to get eaten, and this whole pizza is going to get eaten, but only half of this pizza is eaten. That is 2 whole pizzas and 1 half of the third pizza. This right here is a mixed number. Okay. So all this lesson is trying to get you to understand is what a mixed number is. In chapter 9, we'll be talking about converting mixed numbers to what we call improper fractions, and then going from an improper fraction to a mixed number. But for now, we just want to understand what a mixed number is. So if I have 5 and 1/4, that means I have 5 wholes that are all broken into the same amount of pieces. And then I have another whole broken into those pieces, but only one of them. So all of these are colored in. So this is 5 and 1/4. Sorry, that one's a little messy. Okay. The other thing this lesson does is this lesson teaches you that any number over itself equals 1, because this is like saying 4 divided by 4, and any number divided by itself is 1. It also teaches you that any number over 1 is just that whole number. So if you see a number over 1, it just means that 8 divided by 1 is 8. Okay, which is what we talked about when we were doing division. That fraction bar, that line there, its meaning is divided by. And anytime you have a fraction, you can actually divide it and you'll end up with a decimal. We're not going there right now, but just another thing to understand about fractions. Okay, but for page 102, the 3 things you have to understand are that when you divide a number by itself, so any number over itself is 1 whole. So it's like saying I have my pizza and it has 8 pieces, and I have eaten all 8 pieces, or my family has. We have eaten 1 whole pizza. Okay? And then if I have 5 over 1, that is 5. So I have 1 whole pizza broken up into, I can't do 5 pieces. If I have a square pizza, 5 pieces, 1 whole pizza is 5 pieces. And a mixed number is a mix between a whole number and a fraction. A whole number and a fraction. Okay. The next 2 pages talk about comparing and ordering fractions. Now, if I had done this lesson in class, I would have done these 2 pages together, because if you can compare fractions, then you can order fractions. It's the same concept, and especially with the simpler fractions that they're giving you. So if I have a fraction with the same denominator, and I'm comparing it to another fraction that has the same denominator, all I have to worry about comparing is the numerator. And I can see that 3 is bigger than 5, so 3/5 is greater than 1/5. Okay? So anytime the numerator and the denominator is the same, just look at the numerators. Now, if the denominator is different, that makes it a little bit trickier, but not too bad, because we know how to make equivalent fractions. So if I have 1/3 and 3/12, and I want to compare those 2 numbers, 1/3 and 3/12, I have to ask myself, well, what do I do to 3 to get to 12? In this case, I'm going to multiply by 4. So if I multiply by 4, and I multiply by 4, I'm going to get 4/12, right? So 1/3 is greater than 3/12. I'm going to rewrite that because that didn't really work the way I wanted it to. All right, so 1/3 and 3/12. I asked myself what I had to do to get to 12, and I have to multiply my numerator and my denominator times 4. So I am going to get a new equivalent fraction of 4/12. And so now I have 4/12 and 3/12. And I can see that 4/12 is bigger than 3/12, which means that 1/3 is also bigger than 3/12. And so I would put my greater than sign in between them. The nice thing about this is that you're only having to change one fraction of the pair to find whether or not that one is greater or less than the other. All right, so let's do one more. I know this video is getting a little long. We'll wrap it up after this one and talk more on the next video. So if I do 1/3 and 5/6. So here's 1/3 and 5/6. And I have to ask myself, what do I do to 3 to get to 6? It's a times 2. So times 2 on the top and the bottom gives me 2/6. So if I compare 2/6 and 5/6, I can see that 2/6 is less than 5/6, which means 1/3 is also less than 5/6. All right, I'm going to pause there, give you a chance to digest all this. And again, you can ask any questions in the comments if you have any further questions. The last video, I'll do a little bit more of that and then put them in order, and we'll talk a bit about the word problems.